Now, if you look at the code of most of the data science related repositories, you will find these two import statements for sure. NumPy is typically imported as NP and Pandas is imported as PD. NP and PD. That is the common convention. You can import Pandas as it is. It will work perfectly fine, but this is what people generally do. So let's run this code. I have imported NumPy and Pandas as it is. What I'm going to do next is I'm going to create a NumPy array. From this NumPy array, I'm going to convert it to a Pandas data frame. So I'm creating it using random.randint, which is present in NumPy. I'm going to create it in this format. We have 5 rows and 3 columns that we have specified over here. Now to convert this to a Pandas data frame, all you have to do is use pd.dataframe. This function, pass the NumPy array to it, you will get it as a data frame. Now if you look at the content of this, you can clearly see 2 items that are not present in your NumPy array, right? Here you have the column names. By default, Pandas assigns the column name starting from 1, 2, 3 and 4. This is the column names. You also have row indexes. This also starts from 0, 1, 2, 3 and so on. Now if you look at the type of DF, you will see it as a pandas.core.dataframe. This is the data frame object. Now instead of allowing pandas to create your column and row names, you can also provide the column and row names yourself. When you are creating the pandas data frame, pass in the index and the columns. This row name and column name, I'm passing it over here. On running this, I need to run this code first, then run this. You will have your column and row names correctly marked. So that's a very basic way of creating a data frame. This is not the only way. You can create a data frame from a lot of different sources. You could create it from a dictionary, you could create it from a file. Both of this we will look at it right now. First, let's create it from a dictionary. Here you have a dictionary of key and value pairs. I want the Jan, Feb, March. These should be the column names. And these are the content or the values of your data frame. This is how I would like it to be. To do this, just pass in this dictionary to your pandas.dataframe. Then pass in your index values also. Now this is optional. If you do not pass this index, it will still work fine because by default pandas will assign an index of 0, 1, 2, 3 and so on, right? That will happen. Here we are passing the index as it is. Let's run this. So here you have your data frame. Now the dictionary object, there is no guarantee that the Jan column that you see here will come as the first column, Feb coming as second column and so on, because there is no internal ordering to a Python dictionary, right? There's no ordering to it. If you want the columns present in your dictionary appear in a certain fashion, you need to explicitly pass in the column argument. Here what we are going to do is we'll additionally pass in columns argument. Specify the order in which you want to have your columns. Here I'm passing Mars first. On running this, you will see the data frame has Mars as the first column. This is another very useful way of creating Pandas data frame. So we have seen how to create it from NumPy array. We have seen how to create it from a dictionary. The same concept will work with list also. If you have a list of lists, just pass in that object to Pandas data frame and it will still work, right? Now let's see how to create a data frame from a file. If you have a CSV file, here we have a CSV file under datasets directory. You should get this directory along with this. Now to import this file to Pandas, you can use pandas.readcsv. This is a CSV file. To import a CSV file, use pandas.read_csv. That's it. This one single line will import the data present in your CSV file. Let's run this. So all the data present in your CSV file, including the headers, is available in this object. Now this is a very cumbersome way of viewing this file because all the rows are getting printed out here. What I would like to view instead is just the first few rows. How to do that? You can use this function called df.head. Once you import your file, use df.head to see the first 5 rows alone. If you want to see the last 5 rows, use df.tail. This is a natural step people do. Once you import your file, you want to see the very first few rows. The first function people run on importing a file is df.head. Then the second thing that you would want to know is how many rows and columns are present in your data frame. Specifically, how many rows. You can see that using df.shape. This will return you the number of rows which is 60 in this case, and the number of columns, which is 3 in this case, right? So these are very basic methods of the data frame object. Now sometimes you would want to extract that data frame as it is in its array format. So every pandas data frame is built on top of a NumPy array, right? And you want to extract that underlying NumPy array. To do that, use DataFrame.values. On running this, you will get your NumPy array in its raw format. There are no column names or row names in this array object because this is a NumPy array object. Secondly, as you can see here, this NumPy array contains multiple data types mixed into one single array. Arrays do not actually support that. Arrays must contain only one single data type, whereas pandas can support multiple data types in a single data frame. What I mean by that is, in this data frame, this is a number, this is a string, this is again a number. Now NumPy cannot store this as a float, it cannot store this as a string, and this as a float again. That is not possible. What it instead does is, it converts everything into a data type called object. It converts everything to a data type called object, and all these items here are stored as objects. So that is another convenience of working with pandas. So that's how you import CSV files. Now if you have a different file format, suppose you have a text file which is toothgrowth.txt. In this text file, I still have the separator as comma. But sometimes a text file can have a space as a separator, sometimes a tab character as a separator, or whatever character as a separator. You can just mention what that separator is in this parameter, sep parameter. Just mention the separator and you can simply import it. It will work perfectly fine. This is another way. It supports multiple file formats, remember. Now, third one is you can import the file directly from the internet as well. Let me copy this URL. So this is the file. In this URL, this content is present. Now I want to import this content into pandas directly. To do that, simply paste in the URL as it is here. This will also work. Pandas has read the data present in this URL and showing it to you here. That's very useful, isn't it? Now, not just this, pandas can import directly from the clipboard as well. Suppose you have your data here. Here in this data, I'm just going to copy a portion of this data. I'm going to do Control C. This frame, this area of this data set is copied now. This region alone also I can import. Simply use pd.read_clipboard. Since this is an Excel file, the separator of this Excel file is a tab character that is represented as \t. On running this, that portion alone got imported here. Now if you look at df, only the portion that I had copied has been imported over here. That is still this particular row, right? Till 15.2. Till this point I had copied. Only this data has been imported into pandas over here. So that's a cool feature as well. You don't have to import the entire file as it is. Now, besides this, pandas supports a lot of other file formats. It supports importing data from pickle files, fixed width format, Excel files, JSON, HTML tables, HDFS store, feather, parquet, and so on. All these different file formats pandas supports.